Hi guys, these are your notes for section 9A, and today we're going to be talking about natural logarithms. So let's talk about what we know so far. We know that there's common logs, which is a log base 10, and there's natural log, which is the new one, and then logs with other bases. So you could have 2, 3, x, a, b, whatever you may want. The other thing that we're going to do today is we're going to figure out what the values of logarithms are. We're going to talk about some of the properties of these functions and use some formulas and models and stuff like that. Okay, but today we're really going to talk about this natural log, and what it is a log with a base of a special number that comes up a lot in real world situations, and the number is something we talked about earlier this chapter, and it's a log base e. Okay, so that's what we're talking about today. Any positive number except 1 can be the base of a logarithm. The number e that you studied in lesson 9.3 is frequently used, okay? The reason being is because we said that that value of e comes up a lot in like interest formulas and in some science applications and in calculus. So this logarithm with a base e is helpful to talk about the exponents that go with that e, and that would be your natural log, okay? We don't write log base e. I mean, I guess technically it's not wrong, except we have a special signal because your calculator has a log base e button. What we use is the natural log. It's just called ln. And if you see ln, that means natural log, and it's log base e. I would write this down. It says that n is ln m if and only if e to the n equals m. So we're going with the natural log instead of log base e. Log base e is bad. Natural log is good. This was in your book. This is actually a picture of Mrs. Thurston's old calculator that she used in college. So that's just a little fun fact for you. Okay, here are some examples of that log base e. You don't need to use a calculator on all these. See, they did go ahead and use the log base e, but we're going to switch over to natural log notation here. So they said the natural log of 1 is the same thing as log base e of 1. Well, what is that going to equal? Well, e to what power, let's say it's x. E to what power equals 1? X would have to be, well, e to the 0 equals 1, so x equals 0. So that's why it equals 0. What if I had the natural log of e? The natural log of e is, okay, that's the log base e of e. We don't know what it is. So e to what power equals e? Well, e to what power equals e to the first, right? E to the x is e to the first, x equals 1. Okay, here's another one. Natural log e to the third equals what? Let's say x. Well, it's a log base e, so e to the x equals e to the third, and x has to equal 3. In general, the natural log of e to some exponent is going to equal whatever that exponent is. Let's talk about why. The natural log and e to the x are inverse functions. One of them undoes the other. So the natural log of e to the x, I'm going to take the natural log, this, they cancel out. One undoes the other. I'm left with just that input, which is the exponent x. Same type of thing whenever we had the log base 10 of 10 squared. Okay, these are inverses. 10 to this, then you're just left with the exponents. If I have log base 3 of 3 to the 4th, they're going to kind of cancel out. I'm left with just 4. Something to think about. Okay, what is the value of natural log of 1 over e? Well, natural log of 1 over e is the same thing. And you don't have to write this every time, this log base e. Log base e of 1 over e. So e to some power is 1 over e. We're going to go ahead and equate the exponents here. Let's say e to the x equals, how else can I write this? That's e to the negative 1. X equals negative 1. Alright, how do we use a calculator? There's a natural log key on your calculator. Natural log of 325. Let's go here. There it is. Second natural log of, what did I say, 325? I don't know if that's really what it was, but it's good enough. That's not what I wanted to happen, so natural log of 325, add the decimal, 5.78383. Okay, TI-84 people will not have to put the decimal in. Inspire people, you will. Natural log of 8. Add the decimal, 2.07944. Let's talk about the graphs for a second. If I'm going to graph y equals e to the x, here's what it looks like. That initial condition is 1, so that's where the y-intercept is, because that's 1 times e to the x. E is my growth factor. It's growth because it's 2.71, which is greater than 1. So we're multiplying by 2.71 each time, and here's what the curve looks like. Here are some ordered pairs. This is the inverse. So how do you get an inverse? You switch the ordered pairs. They switch the ordered pairs. It's a reflection over the line y equals x. All right, let's look at some of these word problems. Very much like the section we did on logarithmic scales, you'll be introduced to a formula, and there'll be lots of plugging in. The math won't be too difficult. Here's the formula that we're given. V equals C, natural log of big R. Talking about a rocket velocity. C is the velocity of the exhaust. Big R is the ratio of the mass. With a small payload, a solid propellant rocket could have a mass ratio of 19. So that would be big R. It's 19. Exhaust velocity is C. C equals 2.4. We're going to go ahead and plug it into this formula. Find the maximum velocity. We are looking for V. 2.4, natural log of 19. This is 2.4 times the natural log of 19. Keep in mind that natural log of 19 is just a number. So 2.4 natural log of 19. I'm going to throw in that decimal. Got 7.066. They went to the nearest tenth here. Let's say about. It says about 7.1 kilometers per second. Another example. Under certain geographic conditions, the wind velocity V, so wind velocity, height, h is in centimeters. Here's the formula. V equals K, natural log of h over h sub o. K is a positive constant. Average wind velocity and the other factors. H sub o is a roughness value. Okay, it says H sub o is 0.7. Good to know. Very easy. A value that applies to a lawn 3 centimeters high. So H is 3. Wind velocity, V is 435. We are looking for the constant. Plug in what we're given. 435 equals K times the natural log of 0.7 over 3. We are going to divide both sides by natural log of 0.7 over 3. You could change this to a decimal right away. I encourage you to kind of store it in there as a whole number, as a non-rounded number, I should say. But if you do get a decimal approximation, really take those decimals out so we don't lose much in the accuracy. Where's my calculator? Here it is. 435 divided by natural log of, what was it, 0.7 over 3. And negative 299. So we got a K value of negative 299. Okie dokie. How about this? At what height above the ground is the wind velocity 1500 centimeters per second? Let's clear this out here. V equals K, natural log, H over H sub O. We're looking for H. They want the wind velocity 1500. Oh, I needed my K. What did we say it was about? Negative 299. Natural log of H, and the initial, what H sub O was 0.7. Okay, on this one we're solving for H. We'll divide both sides by negative 299. I already lost the numbers. 1500 divided by negative 299. Oh, too many zeros. Too many nines. I'm really bad at this, guys. Okay, negative 5.01. H over 0.7. I'm going to change this to an exponent now because what I'm looking for is beyond the natural log. So that's e to the negative 5.0162 equals h over 0.7. And then I will multiply both sides by 0.7. So I get 0.7 times e to the negative 5.01672. And it looks like I get an answer that doesn't make sense. 0.004638. So let's see what I did wrong. This is where I miss you. Okay, I'm betting you guys are going nuts right now because I figured out what I did wrong. And it was on the A problem. My K value is wrong. The K should have been positive 299 because when I plugged in H and H sub O, I had them in the inverted order. So it should have been, let's see if I can correct this. H was 3 over 0.7, which then whenever I worked it out, the number had the wrong sign. So it should have been positive, which makes this positive, which makes this positive. So everything's going to be positive here. And at least it's not that hard to fix in the calculator. Not control. I don't want to do that. Why can't I do anything right today? And I get 105, which makes more sense to the problem. At what height would it be to get this velocity? 105. We're talking about centimeters. It's really tall grass. But it seems good. Okay, sorry for that mix-up. Next thing, they want us to put these in order without using a calculator. Okay, log base 3 of 27. Log base 1/3 of 27. Natural log of 3. Natural log of 1/3. What I suggest you do is change these all to exponents. 3 to the x equals 27. 1/3 to the x equals 27. E to the x equals 3. And e to the x equals 1/3. Okie dokie. So 3 to the x equals 3 to the third. Here x equals 3. 1/3 to what power equals 27? Well, let's see how I can change this to 1/3. 1/3 to the x equals 1/3 to the -3. If I have that negative, that moves it to the upstairs, which makes it 27. E to the x is about 2.71. So this is going to be a real approximation here. So let's say x was about 1, because 2.71 to the first power is pretty close to 3. It's an approximation. So x is about 1 here. And x would be about -1 in this case. So if we put them in order, from least to greatest, my smallest number would be this guy. My next one would be natural log 1/3. Then we'd go to natural log 3. And we'd wrap it up with log base 3, 27. When you're ordering these things without a calculator, change them all over to exponents and kind of do some approximation, juggling, guessing to figure out what we have here. Here's your homework that we'll be working on in class when you return. Sorry about the mistake. This is probably a very annoying note section for you. I seek your forgiveness.